All right. So real and rational exponents. You want me to review the rules real quick?
Yes.
So it'd be something like properties of power is what I call them because it sounds neat. You can say it's the rules of exponents if you want to be more official. I don't care. What do you do the exponents if the bases are the same? Add. Right? And then if they're multiplied, if they are divided, we subtract. Okay. Then we can also do power exponents.
Multiply.
You multiply.
I'm gonna shoot you.
Okay.
I feel offended.
But your feelings don't matter to me.
I really don't.
Oh yes.
Oh my
That's legal, correct?
Yeah.
Right.
The other one's killing the puppy dog.
Yeah, exactly. Do you want me to write the what not to do on the board?
Yeah, kill a puppy dog. Do it.
You killed your puppy dog. Yeah.
Not true.
$40.
That's a true statement about an untruth.
Is that killing puppy dogs?
So that did not kill a puppy dog because I put it does not equal. No, it's not lame. It's a good thing. You can easily show that is not true. That relationship is not true with a counterexample. You remember what that is?
Yeah.
You just plug numbers in and see if it works. If it doesn't work, you've shown that it doesn't work. It's called a counterexample. Okay. Trig identities, I think you've probably put like a wall in your minds about those.
Yeah.
Oh yes, the old standby. Right? I think that is it. Okay, here's one more. That I showed you yesterday that some of you already knew and a lot of you didn't.
What does that say?
This is A, so these are fractional exponents, rational exponents now, 1 over n. Okay, that is say same thing as the nth root of A. Okay.
And then for the negative, it's a over 1 over a.
So if you want an example here, 4 to the 1/2 power is the same as the square root, because we don't write the 2 there, right? Of 4, which is 2. Okay. This is where knowing your exponents comes in handy. Yeah, this is the cube root of 125, which is 5. I know that because here's how these work in my mind. 5 cubed is 125, right?
Yeah.
See the relationship? Cubics and rational exponents are inverses.
Like what's the highest in like cube, like square root? I mean, cube roots, squares.
That I know?
Memorize. Like how? What's the
I don't know. I couldn't tell you.
Like what's 17? That's tough again.
17.
Squared.
I think that one through. 16. It's going to be, I'm going to get it wrong.
No, it's not.
296?
It ends in a 9 because 7 times 7.
Okay, moving on. Okay, remember negative exponents. We can have that situation, right? Or we can have that situation, right? So my thinking around this is just do the opposite of what it says. Like if it's on top and there's a negative, put it on the bottom. If it's on the bottom and there's a negative, put it on top. Or we can do this. Do the opposite. Okay. This comes up just as often as any of these. Right? So I think that's all of them. If I forget something, we'll get to it. Thank you. All right, let's talk about a few problems you're going to encounter. There are lots of ways to manipulate these. The goal would be to keep exact answers, so we don't want a decimal here. If you calculated this, I'm not going to count it. So these are all going to be no calculator problems. Okay? Because I'm going to keep it in spaces where you don't have to do 17 squared, which is easy, but
It is?
like 17 times 17, do it out by hand.
Yeah, I thought you meant like square root of 17.
You can combine square roots. Okay, that is perfectly legal because they have the same exponent. You can put them together.
So if it was square root of 14, cube root of 7,
No, not legal.
how do you solve that?
Okay, we can get to it here in a minute. It's probably been a while since you've broken numbers into their prime factorization,
Oh.
right? Seven times 7 is 49, right? What's the square root of 49? Right, so there is your final answer. There are two of them, it's a square root. That's one way to think it through. You can bring one out. Or you can think that's 49. Square root of 49 is 7. Okay. So those should be review problems. Just a quick reminder there. Right. What was your question?
Oh, if it was like square root of 14 times cube root of 7.
We can manipulate this, although it's going to be a mess. It doesn't really help, but since it's been asked, I can do that, right? Now, using my properties of exponents, I can distribute the 1/2. So I get 2 to the 1/2, 7 to the 1/2, and 7 to the 1/3, right? Now, what do I do with these two exponents?
Add them.
You can add them up because they have the same base, right?
Is that 2.5 times 12?
So 2 to the 1/2 power, and this is 7 to the 2/3. A half plus a third is 4/6, right?
Yeah.
Okay, from there we're pretty much stuck because those aren't pretty numbers,
No.
right? Square root of 2 is 1.414, and I could keep talking for the rest of our lives and I'd never even reach the end. It's irrational. That's probably irrational too.
I think it's, isn't it 5/6? 1/2, that's 3/6.
This does highlight how we write that as a root. Does anybody know how to write that as a root?
Would you put the 2 like on the top of the root?
So it's a cube root because we're in the bottom, right? Of 7 squared. Right, so the top number gives us the exponent. The bottom number gives us the root. Okay, that's part of today's lesson. So. Okay, so that one was just an exercise in using your power properties. There's not really a point to doing that kind of thing. All right, let's look at this. Okay, we can distribute this, right? Bring it in. What's 1/4 times 4? 1, right? So c to the first. What's the 4th root of 81? Yeah, nobody knows it. Okay. Which is fine. Yeah. I have the answer right in my book. It's 3.
Did you see?
How do we know that?
It's root of 9,
3 times
and then the root of 9.
81 is 3 to the 4th,
Yeah.
right? So 3 to the 4th is 81. We can now multiply those to get 3c. We're done. Much more simple than before. Again, just an exercise in algebraic manipulations. Right?
Wait.
I didn't hear you
Okay. Okay, here's a couple strategies that you can use to simplify really nasty exponents. Okay. If that is a big number, right, 625?
Yep.
And I mean big, I mean like it's bigger than 10. Okay. If this is a big number, my strategy is to do the root first. Then cube it. Okay. So it makes it a smaller number, then I can cube my smaller number. Right? Does anybody know the 4th root of 625? How did you know that? Was it a guess? You just knew it? Yeah. So the 4th root of 625 to the 3rd power is what we're looking at. But we want to do this first to make it easier, which is 5. Five cubed is? Okay. What if we run into hold on. I have to think that one through real quick. That's gonna work. 8 2/3. That'll work. Is that a smaller or a bigger number?
It's a small one.
It's a smaller number, so I want to square it first. Plus, it doesn't have a nice cube root, does it?
No.
8 does not have a nice cube root. Okay, it's irrational. So if this is a small number, I will square it first. Okay, so the cube root of 8 squared, I am going to do that first. 8 squared is 64. What's the cube root of 64? 4. Huh?
Dude.
Yeah, it has a cube root too.
Oh, it does. How about that?
Well, you get this one after.
Well, I stand corrected, YouTube.
Yeah.
That rock might have hit you in the head.
Okay, I'm good.
That rock.
No, it was a weight bar this morning. Chipped a tooth, actually. It's fantastic.
Hit him in the head.
Yeah.
What was that?
Hit it enough.
Hit yourself with a lot.
My last rep of Mad Dogs.
So sad. Out.
I hit my chin with the bar
Justin was on the back and-
when I went up to press it.
Justin was fighting.
Did it feel good?
So that might be part of it. I don't know. Okay, so yeah, this one we could have cube rooted first. Okay, fine. You got me on that one. But again, if it's a small number, I do tend to think in this manner. Doesn't always work, obviously. But there you go. Okay? Okay, I think we're good there. And let's look at some algebra simplification stuff. You guys all right?
Yeah.
You could throw a marker.
You laughing at your grade?
No.
Okay.
What's he laughing at like that?
If you're good with just using this as is, have at it. Cube root of 64 is, which we already went over.
What?
What's the cube root of s to the 9th?
That's their third.
How do you know that?
Oh, wait, no, it's not. Put it in.
How do you know that?
You divide
Yeah, you just, it
Yeah.
divides.
Yeah.
So because it would be s to the 9 over 3, right? So this would be 3. And this would be t to the 15 over 3, which is 5. Okay, there you go. Simplified. Right? So fractional exponents still, you just divide. I don't like this. Okay, what if we end up with something like this? Whoops, not what I wanted to write.
Is that what is that?
Square root of r to the 7th, s to the 25th. Can we simplify that?
Not, I mean, yeah.
Your answer is going to be kind of a mess, but yeah, you can. This is a square root, right?
Yeah.
Does that 2 go into those nicely?
No.
No, it doesn't. So you have to break them into 6 and 1 and 24 and 1. Those are, right? So now these are even and we can take them out, right? That's a square root. That becomes r to the third. This becomes 12, and then the root rs stays. Okay. So it can be simplified, it's just whatever. Right. All right. Almost there. Lots of little stuff. Okay. How do I solve an equation with the radical exponent?
solve it very carefully.
Okay, that'd be a good starting point. I'm going to subtract 5 very carefully, in fact. Yeah. Oh. 729 is perfect fourth third of some kind. And I can't remember what it is.
13. No. Yeah. No.
It's the fourth root of 9?
Is?
Is it? I'm guessing.
I think so.
This time I'm guessing.
No.
So yeah, so how would I solve this now?
Cubed.
It is the cube root, you're right. Okay, so when I solve this, I want x to the first out the back, right?
Yeah.
I want it to be x equals. So in order to manage that, I have to raise this to the 4/3.
You had to raise the other thing to the 4/3 too?
And I have to do this one too. Right, because 3/4 times 4/3 is 1. So we get x equals. And again, using my big number strategy,
What's the 9? 729.
729 cube root is 9, right? Somebody said. And then 9 to the 4th.
So 729 times 9.
That's past my pay grade.
Big number.
Anybody?
6,561. Right?
I should know that. Okay, so there you go. Okay, so that's solving with an equation with a rational exponent in it. So lots of little stuff in this section. Properties of powers and then just little things.
That's past your pay grade?
No, that's a joke.
I was...
That is my pay grade, doing math.
Okay.
I already wrote down the homework yesterday. Do you want it again?
No.
I'm gonna write it down anyways.
Nope.
You were all here, but
This is weird.
okay. You have like 15 minutes. Use your time wisely.